goodness. One more thing I want to say about this. She split it up, which I love. X is greater than 1. Technically, if I just graphed that, my line would go all the way to the right. And if I just graphed x is less than or equal to 3, I would have that going all the way to the left. But this type of inequality, is it an and or an or? An and. So am I looking where those two colors intersect, or do I just care about having one of them? Intersect. Yeah, they have to both be on there. So that's why we only shade the middle. We will use these colors a lot today. Questions on that one? Interval notation, how would I write this as an interval? What's my leftmost endpoint? 1. What's my rightmost? 3. What should go around the 1? Parentheses or brackets? Parenthesis. And around the 3? Bracket. Perfect. Questions on that one? Next one, Seamus. iPad privileges. Go crazy.
Oh, shoot, sorry.
Yeah.
Wait, how do I erase? I got it.
Yeah, there you go. You might have to use the pen. I think I have my finger off. Yeah, there you go.
So, and then I put the X on the other side first.
I like it. Keep Y positive.
Oh, wait, sorry.
Yeah, it takes a second to get used to. Perfect.
And then I divided by 2. So I got Y 4X. Sorry, my handwriting's bad.
All right, good.
And then minus 9. But 9 is on here, so I just went up 4 from where it would be, because that's the slope. It's 4 over 1. So I got that point there, and I just kept going up 4 and over 1, like that.
Yeah, be a little careful. It's 4 over 1, so we got to go up 4 and to the
right
right
yeah,
one.
Sorry, my fault. Oh, shit.
It's hard because we don't have that bottom point. Perfect.
1, 2, 3, 4. Like that, and then I just like that.
Okay. Anyone see something that we might want to fix? Go ahead.
Oh, shit.
Yeah, dash line, perfect. And shading, perfect. How did we know that that's where we wanted to shade? It's Y greater than, so we choose above the line. How did we know that it was a dashed line? Yeah, it's just greater than, not greater than or equal to. Perfect. Give a round of applause. Thank you, thank you, thank you. Okay. Questions on those two? Go ahead.
So do you record like a camera, or is it just your?
It is just this screen.
Okay.
And my voice.
Okay, you got the microphone in your neck or something?
No, it's just on my iPad microphone, and it hears me. So like you on YouTube, it literally looks like this plus my voice. Okay.
You edit it?
No.
So it's just like
It's literally just whatever you're hearing right now is going on YouTube in 10 minutes.
Oh.
You know what I'm saying?
Yep.
Okay.
All right.
Cool. Okay. Today we're doing the same stuff that we've been doing. We're not learning technically any new methods of solving. So we're still solving inequalities. But now we're going to solve inequalities that aren't so nice and clean and pretty when they're done, and some weird stuff happens, and we can't just like write our answer down, circle it, and be done. We have to actually think about if it makes sense. Before we get into that, we have to really understand the difference between and or. Like I talked about in the warm-up, if it says and, do I need both of those inequalities to be true or just one of them? Both. So and is when both inequalities or conditions are met. And if we remember our Venn diagram, what part of that would represent and? The middle. The middle. Perfect. It's where they intersect. For or, it's either or. I can have this one be true, I can have this one be true, or I can have both be true. So for or, it's either condition has to be met. And if we look at that Venn diagram, does anyone remember what we shaded here? I think I heard it. All of it. Here's the blue one. That's true for blue. This is true for green. We shade, goodness, everything. We shade the blue, we shade the green, and we shade their intersection. Let's do an example as a class so you can kind of see the difference. Starting right now, this side of my room, you are now adults. Congratulations. Happy 18th birthday. On the left, you are still children. I'm sorry. If you are... I didn't get that. Did you try again? If you are a child and blonde, I want you to raise your hand. Child and blonde. Perfect. What about a kid or blonde? I don't have any blondes on this side, do I?
I'm blonde.
If you, oh, there we go. Kid or blonde. Perfect. We added one. Awesome. What about an adult and wearing black? Adult and wearing black. Okay, what about an adult or wearing black? We got some more from this side. Do we kind of see the difference there? Or gives us more options and restricts our set a little bit more. Okay? So, what we are used to doing and what we have been doing the past 2 days is solving these inequalities. And in general, when we solved an and, like in the warm-up, our graph would look something like this. 2 points, line in between them. This is an example of that. X is greater than 3 and X is less than 8. Pause real quick. If you don't have your 2 colors, grab your 2 colors. That can be your own set of colors if you want to use pens or whatever. You just need 2 different colors in your hand.
Why did they both fill?
This was just an example. They would not both be filled for this. They would both be empty. But in general, when we have an and, this is what we're used to seeing. So if X was greater than 3, here's 3. Open or closed circle for 3. Open. Shading to the right or to the left? To the right. What about X is less than 8? Open or closed? Open. Left or right? Left. So my actual solution set here would be just like our picture. Open circles, line in between. It's just where they overlap, where we see both colors. It's and. Does anyone remember what in general an OR graph looked like? Can you show me with your hands what an OR looked like? Yeah, arrows going both ways. In general, it would look something like this. Let's do an example again. Here's my number line. Here's 2. Here's 7. If we look at X is less than 2, open or closed circle. Open. To the left or to the right? Left. And if I ever go too fast, slow me down because I know you guys are switching between colors and I'm not. I'm just pressing buttons. So X is greater than or equal to 7. Open or closed? Closed. Right or left? Right. And if you remember, our solution set here is either color. So this orange part, that's part of our solution. And the 7 and up is part of our solution. We take either or. We only care about one color. And that's in general what it looked like. Starting today, they no longer look like that. We won't have a single one that looks like these today. They're going to be different. And we don't really know what they're going to look like until we actually start solving them. So we're going to do some simple examples where it already gives us the inequalities and we just have to graph them and condense their solution set. And then we'll do some examples where we actually have to solve it. But these first few are solved for us so we can see the different things that might happen. Okay? So what we're going to do is we're going to take each inequality, we're going to graph it in a different color. So this first one, pick a color for it, and the second one, pick a color for it. We're going to graph them on a number line. Then we're going to condense our solutions and redraw it on a new number line. So, x is greater than 3. Open or closed? Closed. Left or right? Or sorry, less than or equal to 3. I don't know where greater than came from. X is less than or equal to 3. Closed. Left or right? Left. X is greater than 8. Open or closed? Open. Left or right? Right. Okay. That's step 1. Graph each inequality separately. Step 2.
I found this on the web.
If you do that one more time, Siri, I'm going to lose it. Step 2. Look at the word in between your inequalities. Figure out if it's and or. This one's and. Am I looking at where I have 2 colors or where I have 1 color? 2. Do I have 2 colors anywhere? No. So from negative infinity to infinity, there's not a single number that works. You guys probably remember it as no solution for this one. There's no overlap. So we have no solution. That will not be an option on your homework. I don't want you to write it like this. Instead, we're going to add some notation. The way we write no solution is this symbol right here. It's like a 0 with a line through it. This stands for something called the empty set. It's a set that is empty. There's no list of numbers in here because there's no number that works. So instead of writing no solution, I want you to write the empty set with the circle and the line.
Do we put the line in the circle or we put empty set or?
It's the circle and the line. This is what you use. This is what your option is on Delta Math. It's a button. You just press it. So if you get no solution, you press that button on Delta Math. Yes? Questions on that one? Let's do the next one. Again, I'm going to label my inequalities and graph them separate. These ones are already solved, so I'm kind of skipping a step. You guys will have to solve them eventually. But it says x is greater than 2. Open or closed circle? Open. Right or left? Greater than. To the right. Boom. That's my orange one. Then it says less than or equal to 7. Open or closed circle? Closed. Right or left? Left. Okay. Step 1, I graph both inequalities separately. Step 2, I look at my word in between. This one's an or. Do I need both colors or do I need just one color? Just one. So I'm starting way to the left. Do I have a color over here? Yes, I have yellow. It's pointed this way. Do I ever not have a color?
No.
What about right here? Do I have color there?
Yeah.
I do. There's yellow there. So I'm good from negative infinity all the way to what? Infinity. I have color over here. I have a mix of colors here, and I have pink over here. And it's an or, and I only need one. So my solution here is negative infinity to infinity. There's nowhere that I don't have colors. I have colors everywhere. This is how Delta Math wants this answer. If you are planning on taking math classes in the future, you might see this notation. I might have mentioned it once or twice. Negative infinity to infinity is the set of real numbers. That's all your whole numbers, your negatives, your integers, your fractions, your irrationals, all those numbers. This is how we write the set of real numbers. It's a capital R, and there's like an extra line on the side. It's like a boldface R. Is that a question?
Isn't there an option for all real numbers on Delta Math, so would it still take it?
I don't think there is on this homework. I think it wants in interval notation. So write it like this. If there is an all real number box button, whatever, press it. But I'm pretty sure it wants negative infinity to infinity. Great question. Any other questions? Let's do another one. Again, label your inequalities. Each one separate. Draw your number line. And then we graph. For x is greater than 3, open or closed? Open. Greater than? To the right or to the left? Thank you.
Right.
To the right. And then less than or equal to 8, open or closed?
Is this bigger, right?
Or sorry, greater than or equal to 8, open or closed? Closed. Right or left?
Right.
Right. Okay. Step 1 done. Then we look at our word. This is an and. So do I need just one color or do I need both colors? You need both. Okay, where do both colors start?
8.
At 8. When do both colors stop? Infinity. Is 8 included? Yes. It's included because there's a closed circle and the purple's going through it. If that was an open circle there, it would not be included. Okay? So 8 to infinity. And Delta Math wants you to graph these condensed solution sets too. So we could graph that. A closed circle at 8, pushing towards infinity. Questions on that one? Okay, the last weird thing that we might see, there's another weird one that shows up in our activity today. But it's another or. I'm gonna label my inequalities. I mark 2 and 7. And then it says x is greater than 2. Open or closed circle on 2.
Open.
Open. Right or left?
Right.
Right. For greater than 7, open or closed?
Open.
Open. Right or left?
Right.
Right. Okay, here, it's an or. Do I need one color or 2 colors?
1.
I just need one. Where do one of my colors start?
2.
At 2. Is 2 included? No. Okay, so we start at 2, not included. When do my colors or color end?
Infinity.
Infinity. I have both colors going this way, so infinity. And if I wanted to graph that, open circle on 2, arrow to the right. And Delta Math today will have you graph it, do interval notation, or it'll have you do inequality notation like this. So one of these two, and then your graph is what your homework is for the most part. Questions on either of those? Okay, I want us to try to do 1 and 2 with the people around us, and this time we're actually solving. So I want you to solve these, get to something more simple like this, and then graph it just like we've been graphing it, and condense your solution set. Does that make sense? I'll be walking around, okay? You're free, go on. Yeah.
Wait, I have a question.
Yeah.
So then what I just did, why is it 2 and 7?
Because it's an or, so we need one or the other.
Oh, okay. And
So, this works because we have one color.
and when it's and, when the colors overlap, that's when the number starts.
Exactly, so we're gonna start this one at 3 because there's only one color here, we need both.
Okay, perfect.
Yeah? Okay.
Thank you.
Well,
Yeah. That's negative.
but you're going to the junior office.
So,
I would just use it. Or you can just take your pause and I can get an answer. It's probably nothing to worry about, seriously. Seriously, I promise. You're probably fine.
with the arrow, because X is less than 1, I always like, you don't have to move it to the other.
Yeah, you're gonna go this
And
way.
then you come back.
Less
Oh,
than?
sorry, I need to move away.
Oh, yeah, good. Okay, good, perfect. And for the other one, same thing, yeah, there you go. That's what I was, yeah, perfect. Yeah.
This is all right because I knew in my head.
That looks good.
6 or
Keep going. Graph them. Because you're not done yet. And then I'll be there in a second. Less than one.
Is less than.
Yeah, good.
What's going on?
-3. Less than x. Between here and here, it changed. The alligator's equal to -3 here, which would be x here.
Yes.
Yeah. You know what I'm saying? Yeah, but then you're good. Then you can graph. For the ors. Yeah, so for or, we only care about where one color starts. So where do you first start seeing color? Do you see color over here?
Is it open circle or closed circle?
Yes. Do we see color at -1? Okay, do we see color at 7? Do we see color all the way to infinity? Yes. So this one would be -infinity to infinity based on this graph. However, here, when we are dividing this 10 by this -2, this would be -5. You see what I'm saying? Other than that, though, just fix your number and then you should be pretty good. Yep, and then I want you to condense it. So write it as an integral. We only care about one color at a time. So we have color way over here. There's one end point, the other end point. Negative. Perfect.
Divide by half.
Perfect. It should be 6. If you multiply by 2 or divide by 1/2, they're the same. Because if you divide by 1/2, multiply over 6. How does that look that direction?
Is this supposed to be -3? Can I just switch my numbers and see what the same? Yeah. Or just do that.
All right, let's work on these first two together. Make sure we're all on the same page. This first one, this very first inequality, this purple one, how would I solve for x? Divide by 2 and we get x is less than -1. I'm going to keep my or. Extra special, we actually, like, for real, need to keep our ors and our ands all the way down because it really matters. The next one, how would I solve for x? Yeah, add 2x and subtract 10. That works. We would get 4 minus 10 is -6. We would get positive 2x on the right. Divide by 2. We get -3 is greater than x. And I'm going to switch it so it's x is less than -3. That's how we like to look at it, is with the variable on the left for the most part. Are we good to that point? Okay, then we graph them. Let me pick another color. There's my other color. So for -1, open or closed circle? Open, left or right? Left. For -3, open or closed? Open, left or right? Left. And then we check. This is an or. So do we care about one color or more than one color? Just one. Do I have color at -infinity? Do I have color to infinity?
No.
No. When does my color stop? -1. Is -1 included? No. So -infinity to -1, not included. What's up?
Does it matter like what order you write in?
It does. Smallest to biggest, always. -infinity is smaller than 1, or than -1. So it's always smallest on the left, biggest on the right. Great question. And then if Delta Math made us graph it, our condensed graph would be just this blank circle and line. Questions on that one? Yes?
So on the right side, on number 1, we subtracted 10 over.
Yep.
We get -6.
Uh-huh.
So So, but they're on the same side. The negative 6 is on the same side as the 2.
I added the 2 over. The 2x, I added it to make it positive over here.
Added it.
Yep, right here. I did negative 2x plus 2x. I added 2x to both sides.
Okay.
If that confuses you, keep your x on this side, subtract your 4 over, and then you're just dealing with a negative, which we should be able to handle, but be careful with it. Okay. Next one. Label my inequalities. First one. What did we end up getting after solving this inequality? X is greater than 4. I agree. If you did not get that, come talk to me later and we'll make sure we're on the same page. This second one we are going to talk about. What would my first step be here? Subtract 4. We get 1/2 x is less than or equal to 3. How do I get rid of the 1/2? Multiply by 2. So x is less than or equal to 6. Draw my number line. Here's 4. Here's 6. Open or close circle for 4. Open. Right or left?
Right.
Right. Here's that one. For 6, open or closed? Closed. Right or left? Left. Okay. Then we take a break and we look at our word. It's an or. Do I care about one color or all the colors?
One.
Just one. Do I have color over here at negative infinity? Yes. When do I stop having color?
Infinity.
Infinity. So here, negative infinity to infinity. Or, what's the special math notation that I could use? All real numbers, yeah, the math script R.
Even though you just care about one color, you go to from negative infinity.
Yeah, because anything on this interval is hitting a color. It's all a solution to this system. Great question. To graph this, you wouldn't actually have any endpoints. You would just have a line on your number line. It would just be a line. Everything is a solution. So on delta math, you start at the smallest point, you drag it all the way over, make sure there's arrows on both ends. Any other questions for that one? Okay. Start working on the last two with the people around you, and then we'll reconvene and make sure we're all on the same page. What's that?
This, in order to get the end into the center.
Oh yeah, I'll talk about it later. Hold on. On number 4, actually, before you start tackling it, I want you to split it up into 2, like Brooke did in the warm-up. I want you to split it up as this first inequality, and then I want you to do the second one. So split it up into 2 pieces. Did that answer your question, Musab?
Yep.
Perfect. Okay, I want you to write that inequality. N's going to go away. What's left?
So let's see, eventually I will get to that.
Okay. Okay, perfect. When is negative 6 greater than or equal to 0? Never. So no matter what we plug in for n, this is never going to be true.
So it's 0.
So not 0, but no matter what we plug in for n, 0 doesn't work, negative infinity doesn't work, positive infinity doesn't work, does anything work? No. So we would say no solution. We got an equation that's always false. If you get one that's always true, all real numbers, which we'll talk about. Like if this inequality was the other way, 0 greater than or equal to -6, it would be all real numbers.
Oh,
Always true. 0 is always greater than -6.
so I wouldn't need to do it.
Nope. Oh, you can ignore it because it's an and. If this was an or, you would have to do this side. Because this could be this option, but it's an and. And nothing works over here, so nothing's going to work for both of them.
So I just do the zeros.
Yep, you're done. Perfect. Thank you. Were you good?
Yeah, they just wanted to know.
Okay.
No, actually, she wanted my mother's email for the nurse, and I was like,
Degenerative disease.
like if it's, my program says that not read school information,
Right.
so I was like, yeah, maybe I can answer it myself or something.
Yeah.
She goes, oh, down there or something. That was went there, and she was like, do you have heart conditions or anything? I was like, no. Oh, okay. She
we're done for long. Sounds good. That's good. You finish those two problems though. If you want to do a little copy. Master. Oh my goodness. Let's just talk about it. Is this on the second one, I assume? All these hands? Yeah, let's talk about it. Second one's kind of fun. Let's crank out the first one and then we'll do the second. Step 1, label. Step 2, solve. What do I get after I solve the yellow one? Yeah, go ahead. I agree, x greater than 3. On the right-hand side, what do I get if I solve the orange one?
X is greater than 1.
Yeah, let's do this one. I'm going to add x and subtract 4. So on the left, 3 minus 4 is -1. And on the right, I added x. So I get this. -1 is less than x. Or, if I wanted to rewrite that, x is greater than -1. Those are my two inequalities. Questions on how we got those? Okay. Then we graph. Here's -1. Here's 3. Open or closed on 3. Open. Right or left? Right. Boom. Open or closed on -1? Open. Right or left? Right. Okay. Then we check our word. It's an and. Do I need both colors or one color? Both. When do both colors start? At 3. Is 3 included? No, because it's an open circle for the yellow, so it doesn't work for the yellow piece. So we start at 3, not included. And are we good to infinity? Yeah. Yep. So 3 to infinity. Questions on that one? Okay, here's the weird one. If I do just the blue piece on the next example, what should I do to solve for n?
-5n.
Okay. Well, let's combine. Let's add 5 to both sides. Let's take it step by step. 5n plus 6 is less than or equal to 5n. Okay. Now what would I do? Subtract 5n. And I get 6 is less than or equal to 0. And I stop. Because when is 6 less than or equal to 0? Never. That never happens. This is an always false statement. Always false. If you get an always false statement, that means no matter what we plug in for n, we can plug in negative infinity, we can plug in infinity, we can plug in 0, we can plug in a fraction. No matter what we get for n, our inequality is never true. It's never going to work. So do we have a solution? No. This one on the left, no solution. And, is this an and or an or inequality? An and. So this blue one, the blue, has no solution. So would there be any number that works for both the blue and the yellow? No. We have nothing that works for blue, so nothing's going to work for both of them. So my answer is no solution. I draw my empty set and I'm done. Be careful though, because if this was an or instead, we would have to do the yellow piece and go through the whole thing and choose that as our solution. The only reason it's no solution is because it's an and one of them didn't work. In general, if you get always false statement, no solution. If you get an always true statement, so if this said 0 is less than or equal to 6, then what do we think our solution is? Instead of no solution, if it's always true, all real numbers. So always false, no solution. Always true, all real numbers.
Can I use a question?
Yes. Go ahead.
When do we know that we have to, solve both separately?
You always have to solve both separately if there are n's in all 3 spots. If there's a variable everywhere.
The same variable?
The same variable. Any other questions before we do our activity? Yes? It won't give you a different variable. They'll always be the same. Any other questions? Okay. When you get up, you can put your markers away. Everyone should have a copy of this paper. If you don't, raise your hand. I'll hand you one. Okay, this one.
Thank you.
Okay. We all see the posters around the room. Yes, the little white ones on the clips. Okay. I want you in a group of no more than 3, so 2 or 3 or by yourself if you would prefer, to start at any station, do the problem on the bottom of it, write your answer in interval notation. What's interval notation? Brackets and parentheses. Okay. So, you're going to do a station. You're going to write your answer in interval notation.